Good morning, students. And yesterday we had our first lecture in quantum mechanics, and it was the Schrodinger wave equation. This was the name of the chapter, or time-dependent Schrodinger equation. So we covered few topics yesterday, and let me brief you regarding these topics today. Okay, what we had studied. So the first thing was, what is a quantum mechanics? You see, you are going to study this book, so you should know what is quantum mechanics, where it is applicable. So the first thing is, you see, we have two types of particles. One are macroscopic particles, and second is microscopic particles. So macroscopic particles are those particles which you can see with the naked eye, and you can see their movement, their energy, their momentum, which can be measured from the Newtonian mechanics, where the Newton's laws are applicable. Because Newtonian mechanics is also called classical mechanics. So in classical mechanics, what we had, you say, for example, a ball is moving, and then if you apply some force, then you can see the ball is moving, how much force is applied, and what will be its momentum, and what will be its energy, what will be its acceleration. So all these things can be measured. So wherever you see, you can apply the Newton's F equal to ma, equal and opposite reactions, where you can apply the Newton's laws. That is called classical mechanics or Newtonian mechanics. But now, as far as these microscopic particles are concerned, for example, neutron, proton, electron, etc. So directly we cannot measure their position, their momentum, their energy, or we cannot see them as such directly. So we cannot measure the various parameters associated with them. तो अब इसके पैरामीटर्स को स्टडी करने के लिए हाउ what is required, कि what is the parameter which is required to measure the various properties of a particle, microscopic particle. So you see, then the quantum mechanics came into existence, which is called sometimes this is modern physics also, or quantum mechanics. So there what we do, we all the particles, they are associated with one kind of wave, we say, and that is called de Broglie wave. Here I have written what is this is, you see, the wave associated with the particle is called de Broglie wave. तो de Broglie wave particles के साथ associated होती है, number one. And what is the main thing which characterizes a wave, and that is called a wave function. That is called a wave function. Every wave is characterized by a quantity which is called wave function. So here you see, I have written what is the behavior of these particles is described by wave function psi, and psi is associated with every de Broglie wave. All right, second thing, and psi, mind this thing, this is a complex quantity. कि अगर किसी भी पार्टिकल के बारे में कुछ आपको जानना है, तो then you should know the wave function, and this wave function is associated with the particle wave, which is called de Broglie wave. तो ये तो आ गया आपके पास कि ये psi क्या बताएगा. Psi is a main thing. This is what, this is a wave function which will tell about the various quantities associated with the particle, its movement, its acceleration, its behavior, its energy, everything is characterized by wave function psi. क्योंकि डायरेक्टली तो हम मेजर कर नहीं सकते, so wave function is defined. And you see, wave function psi as such does not have any physical significance, whereas psi mod square has a physical significance. And what is psi mod square? You see, psi is a complex quantity. So if we take the complex conjugate of it, that is star. So if I say psi star psi, if we multiply psi with its complex conjugate, then you see it becomes real quantity. And this is called probability density. So PRT means probability density. R means at any position, T means at any time. कि किसी भी जगह पे, किसी भी टाइम पे, the probability density is the probability of finding a particle at that point at any given point of time. कि किसी भी टाइम पे आप देखना चाहते हो कि whether the probability of finding the particle is there or not. So what you will be doing, you will take psi mod square. Psi star को psi से multiply कर दीजिए, and that will be a real quantity because particle actually is at some place. Particle कहीं ना कहीं तो पड़ा हुआ है. It means it is a real quantity. And psi as such is what? Psi is a complex quantity. So what we do, we multiply psi by psi star, and then that quantity is called probability density, and this gives us the probability of finding a particle at one particular place. कि एक जगह पे हमें पता लग जाता है अगर हम probability density कैलकुलेट कर लें कि probability per unit volume, कि how much is the probability of finding a particle at this particular place, that is called probability density. Now you should know कि what is quantum mechanics, why it is there, because we have to study the microscopic particle. अब microscopic particle को describe करने के लिए कोई चीज चाहिए which is called wave function, and wave function, so probability of finding a particle must be somewhere, so that is characterized by psi mod square. So this is all about what is quantum mechanics, what is a wave function, what is probability density, and then I talked about, you see yesterday, one more thing, normalization of wave function. What do you mean by the normalization of wave function? Normalization of wave function का मतलब ये होता है कि we write it as such कि PRT, that probability density. If I write PRT, and this thing, we had written this is psi star psi. And if I integrate this from minus infinity to plus infinity, अगर आप इसको इंटीग्रेट कर देते हो over the space d cube r, all right, so this gives PRT, this is psi star psi d cube r. We have taken the integral of this over whole of the space. ये space है, r means position, तो जब d cube r लिखते हैं तो this is in space, so minus infinity to plus infinity, it will cover this space, and it must be equal to 1. If it is equal to 1, it means the probability of finding the particle is there. इसकी वैल्यू 1 आनी चाहिए. 1 का मतलब ये होता है कि particle is there. So if we write PRT, which is equal to psi star psi dqr, means whole space over whole space, if it is equal to 1, then we say that the particle is there, and this is equation. ये जो आपके पास ये इक्वेशन आ जाती है, this equation is wave function which obeys the equation number 1. ये जो wave function है, the wave function psi which obeys above equation is called normalized wave function. Normalized wave function. So wave function is said to be normalized if this equation holds good. If this equation holds good, and the wave function is said to be normalized. जिसमें numericals भी आते हैं कि normalize the wave function. So what you have to do, if wave function is given, you just take its complex conjugate, integrate over the given space, and it must be equal to 1. ये equation 1 करके आपने इसको solve कर लेना है, and then we say that this function is normalized. Number 1. Then I had written what should be the conditions for normalization of wave function. So normalization of wave function के लिए 3 condition थी. It must be single valued, its derivative must exist, and one more condition I had given. So just go through those 3 conditions which I have already supplied you in my notes. तो ये आपके पास ये आ जाएगा normalization wave function and what are the conditions. Thereafter I talked about what is a free particle. What is a free particle? So a particle which is not acted upon by any external force. कोई भी फोर्स किसी पार्टिकल के ऊपर नहीं लग रही, then we say that is a free particle, and then we had written the wave function for a free particle. Wave function for a free particle. So it was a little mathematics which we have done yesterday, and we had calculated the equation. So you can see the notes which I have supplied. So it's a very simple equation. Simply वहाँ पे हमने values put कर दी थी यहाँ पे कि पहले तो एक तो wave है which is moving towards positive x direction. Then it is given by psi xt. A wave which is traveling towards, say, along the positive x direction, it is given by a e to the power minus iota omega t minus kx. ये है wave traveling towards positive x-axis. Remember, you have to remember this equation always, that if it is written psi xt, psi is a wave function, and it is characterized by a wave which is moving towards positive x direction. So psi xt is equal to A is a constant here, e raised to power minus iota omega t minus kx. So what is omega? Omega is what? This is angular velocity, and omega is angular velocity. Omega को आप क्या लिखते हो? 2 pi nu, where nu is frequency, right? And then what is k? K is called propagation constant. Propagation constant. And x, you know, this is towards x-axis. T is the time which you have written. And if I write that k is equal to, k को आप एक और form में लिख सकते हो. K is always written as twice pi by lambda, where lambda is the wavelength. Lambda is wavelength. Nu is frequency. Omega is called angular velocity. Omega is called angular velocity. This is frequency, angular frequency. K is called propagation constant. And moving towards positive x-axis. This is the basic equation, which is the wave which is traveling towards positive x-axis associated with the particle. So how it is written? It is will be characterized by wave functions I xt, and this is very, very important equation which you have to write in this manner. And then if you substitute the value of omega here, omega is equal to what? 2 pi nu. K की जगह लिख दीजिए 2 pi lambda. You take 2 pi outside, and then you can see the equation. Yesterday I had given you this equation. So if you see, after substituting these values, what you will be getting, that psi xt is equal to A e to the power minus iota over h cross into et minus px. Simply, you see your note, lambda is equal to h over p. यहाँ से हमने ये वैल्यू सब्स्टिट्यूट कर दी हुई हैं. We have done this in yesterday's notes. So if you substitute value omega equal to 2 pi nu, k equal to 2 pi by lambda, and then again you can put the values here and then just solve it. After 2-3 steps you will get this equation. So this is very, very important equation. This is very, very important equation, and this is the equation of a particle wave traveling along positive x direction associated with the particle moving, having momentum p and energy E. ये जो wave है which is moving towards positive x direction, it will be having momentum p, energy E at any given point of time t, and iota and h cross is h upon 2 pi, where h is Planck's constant. H bar is equal to h upon 2 pi, where h is Planck's constant. So yesterday we had done this mathematics. तो ये आपके पास इक्वेशन आ जाती है, which is very, very important. You have to remember, this is the wave, this is the equation, this is the wave function which is associated with a free particle, and the wave is traveling towards positive x-axis. So this is very, very important. इसकी ये आपको याद करना पड़ेगा, because we will be using this equation time and again. इसको आपको बार बार देखना पड़ेगा. So just go through that. And so this is a quick revision of my first lecture which we have done yesterday. So just try to solve the numericals based on normalization of wave function. Normalization of wave function पे आप देख लीजिए. Few numericals, you just integrate it and see, because exams में आते हैं कि normalize the wave function. So I can give you few problems regarding the normalization of wave function also. So probably this is enough for you. Just go through that, because a few students, they were registered today even. So I am just repeating this article, these articles which we have covered yesterday, right? So we will be meeting the next lecture next time. Thank you.